This is a very basic overview of object-oriented programming, focusing on classes and objects and how they are related. This really is meant for people who probably have used classes and objects before, but maybe it didn't click how this fit together to object-oriented programming, or maybe you just the way you used them wasn't a very OOP way of looking at it. Um, I guess the other audience might be folks who just haven't done this in a while and want a little bit of a refresher. But the point is, if you're brand new to object oriented programming, this isn't going to go very deep. It's probably not enough to get you started. You'll want to reach out for some other resources. Uh, the concepts that I'm going to talk about hold true across a large variety of programming languages. And I'm just going to talk about general concepts. I'm not really going to look at how you would implement this in your code because that's going to depend on your programming environment, your programming language. So for this video, we're just going to take a look at these concepts and make sure that we understand them going forward. And we'll start with the most basic question of all. What is object-oriented programming, or OOP? So the fancy way of saying this is that object-oriented programming is a programming paradigm. It's really kind of an approach to programming. It has to do with the way you organize your code and how you think about solving problems. In kind of technical terms, we would say that in object-oriented programming, data and the code related to that data are grouped together into a data structure that we call an object, and as opposed to something like functional programming, where the functions and the data are kind of kept separate. So that's, again, very technical, very dry way of looking at it. I'm going to encourage you to take an approach that really tries to make this a little more tangible and try and connect it to your life outside of computer programming. So what I like to say is that object-oriented programming lets us look at our programs the way that we look at the world around us. So most of us, in most situations, we see the world as a bunch of objects that all kind of interact with each other. If you walk into a classroom on campus, for example, you're going to see an instructor, and you're going to see a bunch of students, you're going to see a whiteboard, some desks, a bunch of chairs, and so on. All of those objects have some information that's associated with them. You know, the teacher has a name, the students have names, student IDs, things like that. And each of those objects also has things that they can do or that we can do with them. So a teacher can ask questions, it can answer questions from the students. Teacher can give a test, grade a paper, can give a lecture on object-oriented programming, and students have actions as well that they can take. They can take notes, they can ask questions, they can turn in a paper, they can fall asleep during an OOP lecture. Even things like the whiteboard, we can use that by drawing on it, and then we can keep track of what's written or drawn up there. When class is going on, we see all these things interacting. So the teacher is lecturing and calling on students. Those students are answering the teacher. They're asking questions of their own. The teacher is writing on the whiteboard and the students are taking notes on what they see. You get the idea. Object-oriented programming encourages us to think about our programs in the same way. It is very popular. The truth is you're surrounded by things that are created with object-oriented programming all the time. And so, for example, when you go home and play a video game, it was probably created using object-oriented programming. If you think about something like Fortnite, it's almost like the classroom, right? Actually, classrooms often are like Fortnite, aren't they? But in Fortnite, you're going to have players, and there are going to be weapons and buildings and all the little stuff you can pick up, and the players grab the weapons, they use the weapons, they shoot at each other, all of that kind of stuff. It's a bunch of objects that are all interacting with each other, and it is almost certain that those types of games are created using object-oriented programming, just because it's such an obvious way to look at it. But the truth is, even outside of game development, object-oriented programming is very widely used across a variety of programming needs. In particular, it works great in team development settings because when we break things up into objects, that gives us kind of a natural way to divide the work up between teams by saying, okay, if we're making Fortnite, I'm going to have one team work on the players, I'm going to have another team work on the weapons, and so on. I don't have any data to support what I'm about to say, but my guess is that if you go into software development, you're almost certainly going to be doing some form of object-oriented programming. It might not be 100% of the time, and it might not be the only thing that you do, but it's probably going to be a part of your programming career just because it is so pervasive out there. So this all begins with the idea of classes. And so classes in object-oriented programming can be thought of as blueprints for objects. So if we have blueprints for a house, you can imagine that it tells us all the information we need to know in order to go out and create a house. Another analogy that is kind of popular is the idea of a recipe. So a recipe is going to tell you all the information you need to know to bake a cake, for example. Both of those are good analogies. And let's start talking about our classroom example in terms of classes. One of the objects we're going to see right when we walk in is going to be the teacher. And if there's a teacher object, that teacher had to be created using a class. Obviously, this is a computer program, not a real life teacher. But this is an example of what we call a class diagram. It's a way of visualizing the information that we need to know about a class. There's a pretty universal format for these, and it's called UML. And that's what I'm using here. I'm actually using a very, very simplified version of UML because it can get really complicated and beyond what we need for today. But when you look at class diagrams, they're going to look basically like this, and this format's going to serve you well throughout your career. So this class diagram starts with a name for the class, and this one is called teacher. Notice that it's not called teachers with an S. It's singular because this is a set of blueprints to make one teacher, not to make a bunch, to make one. We can use it. We're going to see we can use it and end up with more than one. But this is a description of what one teacher is. And below the class name, we have all the things that we need to keep track of about that teacher. So in this case, I have a name for the teacher. I have a subject for the teacher. I have the location of their office. You can imagine all kinds of other stuff. And those are a couple other ways to think about this is that these are things that make the object that we create unique. So if I have two teachers, they're going to have different names. They might teach different subjects. They have different office locations. You can also think of this as the things that we know about this object or the things that the object knows about itself, depending on how you want to look at it. But we call those attributes. Okay, so attributes are all of these pieces of information that we associate with a teacher. And below that are all of the things that the teacher can do or that we can do with the teacher. So lecture, call on students, write on the board, etc., etc. These are all, for the most part, verbs, right? So the teacher can lecture, the teacher can answer a question. A teacher can't office location. So office location doesn't make sense down here. I mean, aside from programming, just even verbally, that doesn't make sense. So for the most part, these actions that the teacher can do or that we can do with the teacher are verbs. And these are things that all teachers are going to be able to do. We call them behaviors. All right, so we end up with a class name, the class attributes, and then the behaviors, which are all the things that we can do. If you look around the room and see what other objects are out there, there are going to be probably a bunch of students. And so this is what the student class might look like. Again, class name, some pieces of information associated with the student, name, ID number, grade, and then some behaviors that the student is capable of doing or that we can use the student to do. So answer question, fall asleep, whatever it is. But remember, A class itself is really just like a blueprint. It kind of defines what a teacher is. It defines what a student is, but it's just that set of plans, so to speak. And in order to really use that in our code, in our program, we're going to have to create objects out of that. And so we are going to make a teacher object out of the teacher class. We're going to take that student class and we're going to make a whole bunch of objects, right? We're going to make maybe 20 students to fill up that classroom. So I can use the same set of plans to make as many different kind of objects or copies as I want, but I have to take that step of creating them. And the objects that we made, we refer to each one of those as instances. And so we say that an object is an instance of a certain class. If I go in and I see Mr. Smith teaching in that classroom, Mr. Smith is an instance of the teacher class, and all those students are all instances of the student class. And that word instance leads to this great verb that when we create an object in object-oriented programming, the action itself is called instantiating. We say that we're going to instantiate an object out of that class. And so when we instantiate an object, one of the things we do is we have to give values to all of these attributes. So the teacher has to have a name, a subject, and an office location. The student needs a name, a student ID, and a grade. That's part of the instantiation process so that we have an object that is ready to go, ready to use in our program. One of the things that I've kind of alluded to here, but one of the things that's really great about object-oriented programming is that once I've defined a class, I can use that to make as many instances as I need. So again, there are going to be a whole bunch of students in that classroom. I can just keep instantiating them. I don't have to type all that code over and over and over again. And every time I instantiate a new copy of a new object from that student class, they're all going to get information. They're all going to get values stored in their attributes. And the important thing here is that they're all separate from each other. So we have Javier over here, and he has a grade. If his grade changes, that has nothing to do with Vanessa and her grade. They have the same attributes, but the values in those attributes are independent of each other. So once I've built a house, I've built a bunch of houses with my blueprint, I can paint one of them, and that doesn't have any impact on the other instances of that class. Okay, so we've got a good sense of what our classes are going to have as far as attributes and what we're going to be able to do with them. So now it comes down to implementation. And by implementation, we just mean writing the code. As I mentioned at the start, the way you implement these classes is going to be completely dependent on the programming language you're using. And there are many, many, many languages that support object-oriented programming. I would go so far as to say pretty much all modern languages support objects in some way, maybe not, some support it better or more than others, but they all have some form of object-oriented programming for the most part. There are exceptions. But when we talk about implementation, even though the specifics are beyond the scope of what we can talk about now, there are some general principles that are going to apply no matter what language you're using. And so when we look at these attributes that we decided on for each of these classes, when it comes time to writing the code, those become variables. And you've been using variables since probably about the first day you started programming, or maybe day 2, because you can't get very far beyond hello world before you start needing variables. And so for us, we can now start to think of these as being variables that are now inside of a class and are part of an object. So we tend to use the term instance variables because they belong to the instance of the class. But you also sometimes hear the term field, and you can use those interchangeably as far as I'm concerned. The behaviors that we have kind of decided on and designed, those get implemented as methods. Now, methods might not be a word that you're familiar with. It might depend on what programming paradigm you've come from or what programming language you came from, because uh, this has different names depending on the context. In Java, these are always called methods, for example. But in Python, you may have these little things that you've been calling functions. Well, when you put those functions inside of a class or inside of an object, once they're instantiated, they're now called methods. So it can be a little confusing at first, and I don't make a big deal about you kind of using that terminology incorrectly, but you should get in the habit of referring to them as methods when we are talking about object-oriented programming. The other thing I'll mention about method names, I said earlier that they're generally verbs because they're about what we can do. But the other kind of thing that is true almost across all languages is that they have parentheses at the end of their name. And so if that helps you remember, if you're coming from Python, for example, if that helps you remember that methods are like functions because they have parentheses, then maybe that will help. That is as far as we're going to go with this video. Reach out if you have any questions.